So last class we talked about something called bagging. Now we're going to talk about a concept called boosting decision trees. And so first we're going to talk about the algorithm, then we'll talk a little bit about how to tune these boosted decision trees, and then we'll show how to do this in R. And so this is another ensemble method, like bagging or like the kind of bagging variant, random forest. And so like bagging, boosting is an approach that can be applied to many statistical learning methods. It doesn't just need to be applied to trees, but we're going to discuss how to use boosting specifically for decision trees. And so as a refresher, what does bagging do? So bagging involves resampling from the original training data to make many bootstrapped training data sets, and then fitting a separate decision tree to each of these bootstrapped training sets, and then combining all the trees to make one predictive model. And so note that each tree is built on a bootstrap data set independent of the other trees. And so boosting is similar, except the trees are grown sequentially. And so basically it uses information from the previously grown trees. So this is the algorithm for boosting regression trees. Step 1, you set the f hat or the prediction to 0 and ri equal to yi for all I in the training data set. Step 2, for b1 to big B, you fit a tree with d splits. So it has d plus 1 terminal nodes to the training data x and r. And then you update that f, or that prediction model, by adding a shrunken version of the new tree. And then you update the residuals, ri, to be ri minus this lambda, this shrunken version of the Beath tree. So essentially, we're iteratively updating these ri's, or these residuals here, across each of the trees that we're fitting. And then step 3, you output the boosted model by summing up lambda times this predicted prediction here. So the big picture is, given the current model, we're fitting a decision tree to the residuals. So basically, what's left over that was not picked up by the previous model. And then we add this new decision tree into the fitted function to update the residuals. And then we do it again. And so each of these trees can be small, just a few terminal nodes, and it's determined by a parameter d. And so instead of fitting a single large decision tree, which could result in overfitting, boosting basically learns very slowly. And so by fitting these small trees to the residuals, we slowly improve our prediction model in areas where it doesn't perform well. And so remember what a residual is. The residuals are basically the difference between what the model predicts and what the data actually shows. So what your outcome is versus what the model predicted your outcome to be. And so if you take those residuals and you fit a model to them, you're essentially finding kind of the areas that your initial model didn't do very well, and you're kind of improving on it with this new method. And so that shrinkage parameter lambda basically slows the process down even more, which allows more and different shaped trees to try to minimize those residuals. So boosting for classification is similar, but it's a little bit more complex. The tidy models function is going to handle this for us, but if you're interested in learning more, you can read chapter 10 in the Elements of Statistical Learning book to kind of learn a little bit more about that, which that's also freely available online. If you go to the slides themselves on our website, you can click this link to find it.